Hello, this is some help with the Chapter 9 Technology project. We're going to be looking at Part 1 together. This one is going to use StatCrunch to perform a hypothesis test on a problem from the book. They ask us to enter in name or load the data from Exercise 6, Chapter 9 review exercises into StatCrunch. And you can go ahead and do that through loading it from the StatCrunch group. But instead of doing exercise 6 from the review exercises, I'm going to do problem number 91 from the regular exercises, and I'm just going to do that so the answers aren't all the same for you, but this example should still be a pretty good guide for getting everything done. So I'm going to go ahead and show you the problem I'm working on real quick from the book. So it's number 91. The Subway website lists the number of calories in a 6-inch super turkey breast sub as 333. A consumer watchdog group believes that the true average is actually higher than this. So we can see we're doing a test about averages here, and then they've given us some sandwich calories. So we'd want to enter these in or load them, and I've already done that. So if I go to StatCrunch, here's that data set with 14 data values. So that would take care of the first part of the directions. And now we want to, let's see, using only the sample size given in the problem, comment on the requirements for performing the test. So as we saw when we read the problem, this was a test on averages. And as you can see here from the data, there's only 14 pieces of data. So because n is 14, which is less than 15, and they don't state anywhere in the problem what kind of population distribution we have, we need the population to be normal so that x bar is normal. So if you look at my write-up, I've already gotten started on that because my sample size is 14, under 15, population distribution is unknown. We must hope the population distribution is normal so that x bar will be normal. So that's what we're hoping for. But when you're in StatCrunch, you can check that instead of just hope for it. At least check to see if it's a reasonable thing to hope for. So use StatCrunch to conduct a test of normality, and they give the directions here. And I'm just going to go ahead and do those directions for you. So let's get into StatCrunch, and we're going to go to Stat and Goodness of Fit and Normality Test. Select the column that we want to do the work on, and if you read the directions, it says change this from Shapiro-Wilkinson to Anderson-Darling, so I'll do that. Click on Compute, and this is the result that we want. So I'm going to want to move this over into my report. I'm going to go ahead and use Snipping Tool to do that, so I'm going to have to open that up. And we're going to do a new capture. I'm going to grab this window because I just really need this box right here. And it doesn't really say to do this, but you'll see when we start evaluating this, it's the p-value that we need. So I'm going to go ahead and circle that while I'm in the Snipping Tool so I don't have to worry about doing that later. And do an edit copy. And then let's go ahead and get that out of the way. Go to our report, and I'm going to paste that in. And if I paste it there, it'll be a little funky, so I'm going to move down a line and do it right there. And then let's see how we're doing on the directions. So click Compute, copy and paste the results to your report. So we did that. Alright, so now use the results of that normality test to help discuss whether or not the requirements for performing the hypothesis test have actually been met. Explain in detail, see Chapter 6, Section 5 for guidelines, and you may need to do that to see what conclusion to state, especially if yours doesn't turn out exactly the same as mine. Alright, so I don't have that section pulled up, but I do know how it works, so let's go ahead and look at this, and I've already written it up. So because the p-value equals, so let's see, what was our p-value equal to? Let's fill that in. It was 0.6458, and that's greater than 0.05. One set of directions for what to say if it's over 0.05 and one for if it's under, but this one is over. So because of that, we conclude that there's a reasonable possibility that the population we sampled from is normally distributed. And then how is that good for us? We were hoping we had a normal population. It says that up here. And this doesn't tell us that our population is normal, but it says that's a reasonable thing to hope for, and therefore it's also a reasonable possibility that our requirements have been met. Alright, so that takes care of those first few parts. And then moving on to part E, write out steps 1 and 2 for the hypothesis test requested in the problem. So the key here is you cannot do that without reading the problem. So you're going to have to read exercise 6 to figure that out. I'm going to have to read exercise 91. So if we pull that up, it says perform a hypothesis test to see if the sandwiches contain on average more calories than claimed. And if you look up here, it says the claim is 333 calories. So by reading that, we know that what mu is supposed to be set equal to is 333. And double check that again. And where's the text? Was it? Yeah, 333. And then we want to see if it is actually more than that, so that would be a greater than. So on this one I'm going to type a greater than symbol and 333, and then we want to set our alpha to whatever they said, and if you look at the e-text for that, it says we're going to use an alpha of 0.01, so I can type that in. So these numbers are going to be different for you. Maybe the alpha is different, but you should be able to find all those things by reading the problem that you loaded the data from in the book. So there's steps 1, step 2. You can label those as 1 and 2, or you can just do them either ways. Is okay, I guess. And then we want to perform the hypothesis test. So going back to here, we're done with this. I'll go ahead and close that up. Now we want to, so let me show you what I'm doing here. So I'm doing these steps right here. Choose stat T statistics, 1 sample with data, and then blah blah blah. I know what to do there, so I'm just going to go do it, but you have your detailed directions right there. So I'm going to choose stat, and then let's see, it is with averages, it's a t-score, so we're going to do t-stats. We just have 1 sample and we have the data from there. This is very similar to what we did with confidence intervals. We're going to select calories, and then we selected this for a confidence interval before. Now we just want this check for a hypothesis test. Make sure you change the mu from equal to 0 to equal to whatever you read in the problem, which in this case was 333, and that'll automatically fill that in because these always match. And then we're not doing a does not equal, we're doing a more than, so we'll change that to a greater. And then that's all we need. So we can go ahead and click compute. And what we're going to get here are 2 key things: the test statistic, which is the answer to step 3, and the p-value, which is the answer to step 4. So I'm going to capture this, and I'm going to use the snipping tool again. I just think that's a convenient way to do it so we can get this sort of circling done. I want a new snip. So I'll go ahead and capture that. And notice that it says your HO and your HA. They use HA instead of H1, but same idea. And then this is our answer to step 3, our test statistic. So we can go ahead and circle that, and maybe even put a funky little 3 right there. And then the p-value is our answer to step 4, so same thing, circle that. Do the best we can with the mouse to throw a 4 on there, and then edit copy. Head over to our report, we'll put that in right here. Control V to paste it in. And now we've got steps 1, 2, 3, and 4. And I'm going to go ahead and stop the video here, but you would continue on with the directions. In this particular case, our p-value is bigger than alpha, so we could go ahead and reject HO because this is an acceptable, actually, sorry, back up, the p-value is greater than alpha, so if we were to reject here, this risk would be almost 12 times bigger than that, so we cannot reject HO even though we want to. The risk of making a type 1 error is too big, so we would say do not reject HO to avoid that. Then we would state our conclusion in words. There's not enough evidence at the 1% significance level to show, let's see, that the true average amount of calories in this type of sandwich is greater than 333, and so on. So you'll be doing the same sort of stuff, only with the problem that you loaded the data for and with the different numbers and settings that you had. Hopefully this example will help that go smoothly. Good luck.